Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I teach online seminars for exams P, FM, IFM, and LTAM, and I wrote study manuals for those. And you can see here where they're available. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P. A group insurance policy covers the medical claims of the employees of a small company. The value V of the claims made in 1 year is described by V equals 100,000 Y, where Y is a random variable with density function equal to K times 1 minus Y to the fourth for Y between 0 and 1 and 0 otherwise, where K is a constant. What is the conditional probability that V exceeds 40,000 given that V exceeds 10,000? And here's the solution. So we don't know that parameter K, but we know that the integral of density has to be 1, and the density is 0 outside of the interval 0, 1. So if we take the integral from 0 to 1 of the density, where it's positive, K times 1 minus Y to the fourth dy, that has to be equal to 1. But that integral is equal to minus K over 5 times 1 minus Y to the fifth, and we evaluate it from 0 to 1, and this is equal to K over 5. And that means that K must be 5. And we talking about the probabilities of V being greater than 10,000 and being greater than 40,000 in the conditional probability calculation that we need to do. So let's find these two probabilities. So what is the probability that V is more than 10,000? That's a probability that 100,000 Y is more than 10,000. So that's a probability that Y is more than 10,000 divided by 100,000, which is 0.1. And that's just the integral from 0.1 to 1 of the density that we have, which is 5 times 1 minus Y to the fourth dy, and that integral is equal to minus 1 minus Y to the fifth, evaluated from 0.10 to 1, which is equal to 0.9 to the fifth, or approximately 0.59. While the probability that V is more than 40,000 is the probability that 100,000 Y is more than 40,000, which is the probability that Y is more than 0.4. And that's the integral from 0.4 to 1 of the density, 5, 1 minus Y to the fourth dy, which is minus 1 minus Y to the fifth, evaluated from 0.4 to 1, which is 0.6 to the fifth. Or approximately 0.078. And the probability that we're trying to find is the probability that V is more than 40,000, given that V is more than 10,000, which is the probability that of the intersection of the two events, V is more than 40,000 and V is more than 10,000, divided by the probability that V is more than 10,000. Of course, the intersection in the numerator is simply the probability that V is more than 40,000. And this is approximately 0.078 over 0.590, and that's approximately 0.132, which is answer B. Please remember this is copyrighted material. The problem itself comes from Society of Actuaries. It belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.